Okay, good afternoon, folks. We're going to go over what we talked about in stats today. So today we kind of got into our quantitative data. So we'll go ahead and take a look at the practice I gave you. I'll kind of go over some of the definitions. So here's what we got. Quantitative data, there's really, actually a bunch of different ways we represent it. There's a dot plot, and a dot plot is, and it's actually one word, not two, it's one word. Dot plot, it's kind of like what we did with the Parkinson's thing. We have our numbers down at the bottom. So, we would do like 1, 2, 3, 4, 5, 6. And then we'd have corresponding dots over the number. So, if I had something like this, that would be a representation of whatever it might be, the number of AP classes you're taking or something. So that's a dot plot. Dot plot are dots over a line. You then have a histogram. And a histogram is, so that like this is a dot plot we'll talk about. Histogram is basically turning those dots into bars. So it'd be something along the lines of this. It's basically turning that dot plot into a histogram. Again, 1, 2, 3, 4, 5, 6 kind of thing. I should have 2 bars in there. So that's a histogram. A stem plot, honestly, folks, it's basically, if I do that, that's a stem plot. We're going to do an example of a stem plot here at the bottom. This is called a back-to-back stem plot. I'll talk about it when I get there. That's a back-to-back stem plot. And I briefly mentioned it today, but we'll get into a little bit more detail in the next class, is we also have what's called a box and whisker or a box plot. And a box plot, that's what this is. It's called a box plot. It's made up of the minimum value. It's made up of quartile 1. It's made up of the median. It's made up of quartile 3, and it's made up of the maximum. It's a way to visually represent data. So what's going to happen is we're going to get a bunch of data, a bunch of numbers, and what we really want to do is we want to represent that number. Just a list of numbers sometimes is helpful, so we can turn it into a pictorial representation, a graph representation, so we can understand it a little bit better. So instead of me giving you the numbers, like basically these numbers are like 11, 13, 14, 15, 17, 17, 18 3 times, 19 3 times, and 20, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 29 times. So like 29 times. Instead of just having this list of 21 scores, I can represent it visually so you can see something. So first question says, what percent of students scored higher than 16? So when you say higher than 16, that's 17 or more. I mentioned in class, there's a difference between higher than 16 and 16 or higher. So if I said 16 or higher, 16 or higher would include 16. Higher than 16 would be 17 and above. So in this case, anything that's 17 and above, what we're talking about is counting all these dots up. I'm actually going to make my life a little bit easier. Rather than counting the numbers that I want, I'm going to count the numbers I don't want. 1, 2, 3, 4. There's 4 numbers that I don't want. 17 out of 21 are what I do want. And then I would grab my calculator, and what I would do is I'd figure out 17 out of 21. So in this case, again, I know it says percent. What I'd always recommend you do when you do percent is always show that fraction on how you got it. So it's 0.8095, so it's a little, about 81%, but always show that fraction. So work, answer. This oftentimes on a free response question will only get you partial credit, that'll get you full credit. Okay. Now, next thing says describe the shape. Realistically, honestly, there's 3 shapes that we're going to look for. The 3 shapes we are going to look for are, and I'll do them on the back. First shape we're going to see is this. That looks like my left foot. This is skewed left. The tail points to the left side. This is the next one. This is skewed right. The tail is pointing to the right. And the last one that we would typically see is something that looks like this. And this one is going to be called roughly symmetric. And I mentioned in class, always put the word roughly in front of it. There was a year where they actually penalized people who didn't put roughly in front of it. So that's roughly symmetric. So realistically, these are the 3 most common shapes that you're going to get. There's a couple other ones that pop up from time to time. One of them is this guy. he's technically a roughly symmetric one, but this guy is uniform. Anytime you have something that looks like a rectangle, you're talking about uniform. But if you were to call it roughly symmetric, that'd be right as well. So now we're looking at this and we're saying, what is the shape of this distribution? If you actually take a look at the shape of this distribution, it's got a tail pointing to the left, big bubble on the right. This is a skewed left distribution, skewed left. Again, the way I say, if you think about it, like the big toe on your left foot down to your little toe, kind of skewed left. Are there any potential outliers? Okay. In order to determine that, we actually have to do a little bit of work. So what I'm going to do is I'm actually going to talk about some of these other measures we talked about. So today what we actually talked about is we talked about this acronym CUSC, C-U-S-S-C. When I'm talking about a distribution, what I need to do is I need to talk about the shape of the distribution, the spread of the distribution, and the center of the distribution. Like that's how you represent it. And that last C is for context. So this is really my shape. It says my shape is skewed left. Are there any potential outliers? So what I need to do for outliers is I'm going to need to figure out my spread. My spread is important to figure out outliers. Well, in this case, the spread that I'm going to use for this is either going to be the range or the IQR. But since I'm trying to find outliers, it's going to be the IQR. Now, in order to find the IQR, we're going to need to do a little bit of work. And that work we're going to need to do is we're going to need to figure out the median, we're going to need to figure out quartile 1, and we're going to need to figure out quartile 3. So here's how you figure out the median. Median is the middle number when they're in ascending order. These are in ascending order. I've got 21 data items. So to figure out the middle one, I'm going to do 21 divided by 2. That's going to give me 10.5. So realistically, the 11th item is going to be my median. So what I'm going to do is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That guy right there, this one right here, that's my 11th item. So what I'm going to say is that 19 correct, because we're talking about questions. 19 correct is my median. I've actually talked about the center of this distribution, and I've thrown context in. This skewed left gave me my shape. And now what we need to do is we need to talk about spread. The easiest way to get spread, the simplest way to get spread is range. That's the simplest way. But it doesn't help me with outliers. Range is always going to be max minus min. So in this case, my maximum is 20, my minimum is 11, 20 minus 11, 9 correct is my range. Okay, I'm going to tell you that's great. If I was using it to describe spread, I would have checked the box, but that does not help me when it comes to figuring out outliers. I need to know IQR for outliers, and IQR is going to be Q3 minus Q1, the difference between these two, the middle 50% of my data. And the way I'm going to figure that out is as follows. This is my median. This is my 11th item. So there's 10 before it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 before it, and there's 10 after it. So what I need to do is I need to figure out the middle of the lower half, and I need to figure out the middle of the upper half. There are 10 data points in the lower half. There are 10 data points in the upper half. Halfway through 10. 10 divided by 2 is 5. That's an even number, so I want to find the 5th and the 6th entry. And what I want to do is I want to take their average. So 1, 2, 3, 4, 5, 6. These two are my 5th and 6th. Unfortunately for me, they're both 17. Divide by 2, divide it in half. Tells you my quartile 1 is 17, correct? And now I'm going to do the same thing for my upper end. I'm going to count from here. You could count from here, or I can count from the high end. 1, 2, 3, 4, 5, 6. In this case, they're both 20. So 20 plus 20 divided by 2 is 20. So my quartile 1 is 17. My quartile 3 is 20. And to figure out the IQR, I figure out the difference, 20 minus 17. So that's 3. So my IQR is 3 correct. And now to figure out outliers, the way you're going to figure out outliers is as follows. Can I jump back here? I know my Q1 is 17. I know my Q3 is 20. I know my IQR is going to be their difference, or 3. To figure out outliers, I take Q1 and I subtract 1.5 times that value of IQR3, Q1. Then I take Q3 and I add 1.5 times 3, that IQR. So the rule for figuring out outliers is you take 1.5 times the IQR, you subtract it from the lower quartile, you add it to the upper quartile. So in this case, that's going to be 17 minus 4.5. That's going to give me 12.5. That's going to be 20 plus 4.5, because 3 times 1.5 is going to give me 24.5. So any values bigger than or smaller than 12.5, any values bigger than 24.5 are outliers. There's nothing bigger than 20, so there's no high outliers. We do have one low outlier. So in this case, we have one low at 11. And the reason being is because of this work I did back here. And yes, you do need to show the work for both ends. Okay. So it's a little bit longer, but I want to kind of hit on some things. So now what I'm going to do is I'm going to talk about a back-to-back stem plot. So when I look at a stem plot, let me talk about some of the important things on a stem plot. This piece here in the middle is called the stems. These one out here are called the leaves. So the numbers in the middle are the stems, the numbers out here are the leaves. You should always have a key here explaining what these numbers mean. So 8.6 or 8.2, for example, 8.2 means a pulse rate of 82 beats per minute. So now what I'm going to do is compare these two distributions. When I compare them, I'm going to compare their centers. I'm going to compare their spreads. I'm going to discuss their shapes. And I'm going to discuss if there's any outliers. Now, when I say comparing center and spreads, what I need to do is I really need to be specific about comparing. I need to say is greater than, is less than, is the same as. I can't say one's median is 82 and the other's median is 72. I want to say this guy's median is larger than that guy's median. So if I look at this guy right here is my stem plot for after exercise. So let's start there. If you look at a stem plot, I'm being honest with you. If you rotate it 90 degrees and look at it right here, it's basically a dot plot where instead of dots, we put down the numbers. So if we looked at this and we wanted to describe the shape of this guy, that guy is skewed right. So what it would tell me is my after is skewed right. And now I need to find the center. So what I'm going to do is I'm going to find the after's center. There are 19 items here, so 19 divided by 2 gives me 9.5. So I'm going to go ahead and look at the 10th item. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10th item. So my median is 98 beats per minute. I use median because I'm talking about a skewed distribution, but anytime you're given a graph, I would stick with median as my measure center. Now what I'm going to do is I'm going to look at spread. And my spread again could be my range. So if I wanted to, I could do the maximum value 146. 146 minus my minimum value 86. So I could say that my spread is 60 beats per minute. That's my range. But what I'm going to do is I'm actually going to look for my IQR, the middle 50% size. And the way that I'm going to do is I'm going to look for the middle of the lower 10, the middle of, I'm sorry, of the lower 9. My mistake, the middle of the lower 9. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 below it. 1, 2, 3, 4, 5, 6, 7, 8, 9 above it. So the middle of the lower end, or my quartile 1, is going to be 1, 2, 3, 4, 5. My quartile 1 is 90. My quartile 3 is the middle of my upper 9. 1, 2, 3, 4, 5. My quartile 3 is 104. Minus 104. So that tells me my IQR is 14. So now to figure out outliers, I'm going to do that 1.5 times that IQR of 14. That gives me 21. I'm going to take quartile 3 plus 21. So 104 plus 21 gives me 125. So that tells me I have one high outlier. I'm going to do quartile 1 minus 21. So I'm going to do 90 minus 21. That's going to give me 69. So I have no low outliers. So I've done that for after. Now I got to do it for before. So what I got to do is I got to go through. I've described after. Now I got to describe before. Here's the deal with before. Be cautious. I'm going to go ahead and look at the resting, or it's not before resting. Sorry, resting. Be careful. When I look at it this way, if you notice the number line is running the wrong way, it's big numbers to little numbers. So whatever I conclude, so when I look at the shape, to me, it looks like it is skewed to the left. It looks like it's skewed to the left. Looks like the left foot, but everything is backwards. This is actually skewed to the right. So resting is also skewed to the right. What I need to do, and since ink is running out, I'm going to switch to red. We're going to find our center. Our center is going to be 19 divided by 2 again, so it's going to be our 10th entry. Start from the inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10th entry. It's 76 beats per minute. I'm going to go and do my IQR again. So again, it's going to be Q3 minus Q1. So what I want to go ahead and do is I want to go ahead and compare the 5th entry. 1, 2, 3, 4, 5. 71 is my Q1. 1, 2, 3, 4, 5. 88 is my Q3. That's going to be 17. Again, multiply times 1.5. 17. So what that's going to give me is half of 17.5 is 8.5 plus 17 is going to give me 25.5. What I'm going to do is I'm going to add that to this end. So I'm going to do 88 plus 25.5. And that is going to give me 100 and let me make sure I get it right. It's going to give me 113.5. And I'm going to notice that there's one high outlier. This guy right here is an outlier, so it has one high outlier. And now I'm going to do 71 minus 25.5. That's going to give me a number in the 40s. There's no low outliers. So now what I have is I have my after, I have my resting, but this isn't what it's asking. It's asking to compare. So to compare, I'm going to say both distributions are skewed right. I'm going to say the following. After has a smaller median. And if we look at our IQR, what we find out is that after has a smaller median and a smaller IQR than resting. And I would say both have one high outlier. And what I need to do on this one is, in this case, I haven't put any context in. What I'm going to say is both distributions, and I would say both distributions of beats per minute are skewed right. After has a smaller median and a smaller IQR than resting BPM. Both have one high outlier, and what I've done is I've compared them. So a little bit longer video. We're going to practice this again in class. I'm going to give you a FRQ to work on. And in that FRQ, what we'll be able to do is we'll be able to kind of walk through that example. So hopefully that helped. Please use the reflection if you have any questions. And I hope you have a good weekend.